Welcome back. In week 3, we learned how your C# code becomes machine instructions and how memory is organized. Now in week 4, session 1, we'll master loops, the way to repeat code without rewriting it. By the end of this session, you'll know when and how to use each type of loop and how to avoid common errors. Let's get started. This is week 4, session 1, Mastering Loops in C#, a beginner's guide to loops. We'll explore why loops are essential, how they work, and how to write them correctly. Imagine you need to print hello 10 times, process 20 items in a product list, or keep asking the user for valid input until they comply. Would you really type the same line of code 10 times? Clearly not. Loops are the smart way to handle repetition, one definition, multiple executions. By the end of this slide, you should ask yourself, how could I avoid typing near identical code over and over? Loops are the solution. A loop is simply a programming construct that allows a block of code to run multiple times without you rewriting it. Think of it like a supercharged copy and paste or a recipe instruction that says, repeat steps 3 through 5 until the mixture thickens. Using loops saves you time and reduces errors because you maintain one block of code instead of many copies. By the end of this session, you will be able to identify the 3 main types of loops in C#. Explain when each type is most useful. Write simple C# programs that use loops. Debug common loop errors, such as infinite loops and off-by-one mistakes. Keep these goals in mind as we move forward. Before you write any loop, ask yourself 3 essential questions. What code should repeat? That is, what block of instructions goes inside the loop? How many times or until when should it repeat? In other words, what is the loop's stopping condition? How should things change on each repetition? Typically, this means updating a counter or changing the state of a variable. Any loop you write must address all 3 questions to function properly. C# offers 3 loop types to answer those questions. The for loop, which is ideal when you know exactly how many times to repeat. For example, do this exactly X times. The while loop, which continues as long as a given condition remains true, useful when you don't know in advance how many iterations you need. The do-while loop, which always runs the code block at least once before checking the condition, perfect when you want to guarantee one execution before testing. We'll explore each in depth. Let's start with the for loop. Its syntax looks like for, start, condition, change, code to repeat. The start section runs once to initialize a counter. The condition is evaluated before each iteration. If true, the loop body executes. The change section runs after each iteration to update the counter. This structure directly answers our 3 loop questions. The code to repeat is inside the braces, the condition defines how many times we run, and the change tells us how to move from one iteration to the next. In this example, we count from 1 to 5. Here I starts at 1. Before each repetition, the loop checks if I is less than or equal to 5. If so, it prints the current value. After printing, it increments I by 1. Once I become 6, the condition fails and the loop stops. This is the simplest use of a for loop. Now let's personalize that pattern. Suppose you want to display personalized greetings for 3 students. The loop variable student goes from 1 to 3, and each time we print welcome student number 1, number 2, and number 3. The logic is identical to our counting example. We just changed the loop variable name and the message. For a countdown from 5 to 1, you simply reverse the initialization and condition. Here, countdown starts at 5. The loop continues as long as countdown is greater than or equal to 1, and we decrement by 1 each time. Once countdown reaches 0, we exit the loop and print blast off, so. Even for loops can go wrwrong if we forget one part of the structure. 2 typical errors are infinite loop if you initialize I equal 1, check I less or equal 5, but omit the I++ increment, the condition always stays true and the loop never ends. Off by 1 error, if you write for int I equal 1, I less 5, I++, you actually loop from 1 to 4. Some beginners expect it to run 5 times, but it only runs 4 times. Always verify that your start, condition, and change align with your intended iteration count. Next up is the while loop. Its syntax is while, condition, want code to repeat. The condition is evaluated before each iteration. If it's true, the loop body executes. If it's false right away, the loop never runs. You must be careful to change something inside the loop, typically a counter, so that eventually the condition becomes false. Otherwise, you'll create an infinite loop. Suppose you want to print a message 3 times using a while loop. You could write while count less or equal 3 console.writeLine. Count $. Here, count starts at 1. Before each iteration, we check count less or equal 3. We print the message, then increment count. When count reaches 4, the condition fails and the loop stops. If you forget count ++, the loop never ends because count remains 1 and 1 less, or equal 3 is always true. A very common use of while loops is to validate user input. Here we keep asking until the user enters exactly yes or no. The condition answer not equal yes, empty answer not equal no means as long as the answer is neither yes nor no, repeat. Once the user types a valid response, the loop ends. As with for loops, you can create infinite loops if you never update the condition variables. Here, x is never incremented, so x less or equal 5 is always true. The correct version adds x++ inside the loop. Always confirm that your loop can eventually reach a condition where it stops. The do-while loop executes its body at least once before checking the condition. Because the condition appears after the loop body, we are guaranteed one execution. This is useful when you want to show a menu or prompt before validating input. Consider a simple menu that you want to display at least once and then repeat if the user's choice is invalid. Because the menu is shown before we check choice, the user always sees the menu once. The loop repeats until they pick a valid option between 1 and 3. Now let's practice diagnosing a broken loop. Consider this code. Your tasks. Predict what this code will do. Identify the error, fix the code, explain why the original was wrong. In this case, using I means I keeps decreasing, so I less or equal 10 is always true and you end up in an infinite loop. The correction is to use I++ instead. For your lab, you will build a customizable countdown timer. The requirements are: ask the user for a starting number. Use a loop, either for or while, to count down from that number to 1. Display each number during the countdown. After reaching 1, print time's up. Optional, add a 1-second delay between prints for a real-time feel. This exercise reinforces loop structure, user input, and output in a fun, practical way. Do you have any questions about for, while, or do-while loops? If not, here's a preview of our next session. We will explore how to control loops with break and continue. We will learn about nested loops, loops inside loops, for processing grids or multidimensional data. Keep practicing loops in simple programs. They are fundamental to all programming. And that wraps up Session 1 on loops in C#. You now understand how to repeat code efficiently with for, while, and do-while loops, and you know how to avoid common pitfalls like infinite loops and off-by-one errors. In our next session, we'll put these concepts into practice with hands-on exercises, writing countdown timers, menu systems, and more, so you can cement your loop skills and build real-world programs. See you there.